The non-graphing calculator part of the test will ask you questions dealing with graphing and labeling parts of a quadratic function. You'll have to solve some quadratic equations in the different forms. You won't have to do one by completing the square. You will have to simplify some radicals like the square root of 50, operations with complex numbers, and then you will do some converting between forms like taking standard form and making it vertex form by completing the square, or taking standard form and putting it into root form, or changing root or vertex form into standard form. And you will also get some questions from previous material. So to start with, we'll look at some examples of graphing and labeling a function. First one would be x squared plus 8x plus 15. This is standard form. And so in standard form, we would need to find the line of symmetry first. And our line of symmetry is going to be x equals the opposite of b, which is 8, so negative 8 over 2 times a. And so our line of symmetry is going to be a negative 4. And then if we want to find the vertex, we would substitute a negative 4 into our function for the x value. A negative 4 squared is 16, minus 32 plus 15 is going to get you a negative 1 for the y value. And because it is in standard form, this is the y-intercept. And if you didn't remember that the c term is the y-intercept, you can also substitute a 0 in for the x's, and 0 squared is 0 plus 8 times 0, which is still 0, and then plus 15, and you still get 15. So 0 comma 15 is the y-intercept. And since the x squared term is by itself, it's the same width as x squared, and it opens up. And so then if you wanted to sketch the graph of this particular function, we know that our line of symmetry is at a negative 4. The vertex is at a negative 4, negative 1. And it is a y-intercept of 0, 15. And then that means if this is 0, 15, then we're also going to have another point over here at a negative 8, comma 15. And our parabola would look like this. And that's all you would need to do for something like that. Another example would be this particular equation, which is vertex form. And in vertex form, the easiest thing to find would be the vertex, which in this case is the opposite of that, positive 2, and that, which is 27. The other nice thing to find would be the line of symmetry, which is at x equals 2. Since there is a 3 out in front, it opens up, and it is quite narrow. And then you can also find the y-intercept. And in this case, to find the y-intercept, you have to substitute a 0 in for x and simplify it. 0 minus 2 is a negative 2, and a negative 2 squared is a positive 4, and 3 times 4 is 12, plus 27 is 39. So 0 comma 39 is the y-intercept. And now we have enough information to sketch our graph. So there's 2, which is our line of symmetry. 227 is our vertex, and 039 is the y-intercept. And since 039 is a point and 227 is the vertex, then we have a point over here on this side of our line of symmetry that is going to be at 439. And we can sketch our parabola. Moving on to the last one of this. This is root form. And in root form, the easiest thing to find would be the roots or the x-intercepts. And in this case, it is going to be 3, 0 and 14, 0. And And so we know then here is 3 and there is 14. Now then to find the line of symmetry, it's halfway in between 3 and 14, so 3 plus 14 divided by 2 is 8.5. And so right in here, x equals 8.5 is the line of symmetry. And those are the roots. So of these numbers on the outside of our square root can be divided by 2. We can do that and turn this into a negative 3 plus and minus the square root of 23 all over 2. And if you want to write those as proper numbers and things, you would write a negative 3 halves plus the square root of 23 over 2, and also a negative 3 halves minus the square root of 23 over 2. And if this were in a story problem, then you would take these things and put them in your calculator to get the decimal equivalents for those. Finally, adding and subtracting and multiplying complex numbers. Actually, so for this part, when you're adding or subtracting, you just combine like things. So here 3 and a negative 8 is 11, and a negative 4 and a positive 5 is a plus 1i. For subtracting, 3 minus 8 is a negative 5, and a negative 4 minus 5i is a negative 9i. Multiplying, then you have to distribute. 3 times 8 is 24. 3 times 5i is 15i. 4i times 8 is a negative 32i. And a negative 4i and a negative 5, or and a positive 5i is a negative 20i squared. And we know that I squared is the same as a negative 1. And so a negative 1 times a negative 20 is a plus 20. And so now that turns into plus 20, and our final answer is 44 minus 17i. Then with dividing of complex numbers, just like with square roots, you have to get I out of the denominator, so we have to multiply by a form of 1, which in this case is going to be 8 minus 5i. These two things are called conjugates. So now we multiply. 8 times 8 is 64, minus 40i, plus 40i, and minus 25i squared. In the numerator, 24 minus 15i minus 32i and plus 20i squared. So then we know that 20 turns into a minus 20, and 24 minus 20 is 4. And then a negative 15 and a negative 32 is a negative 47i. And in the denominator, negative 25i squared becomes plus 25. So 64 plus 25 is 89. And a negative 40i and a positive 40i go away. And so we're left with 4 minus 47i over 89. If you want to write it as a complex number in proper form, it would be 4 over 89 minus 47 over 89i. You can leave it like this if you would like to. And understand that if these numbers, if all three of them you can divide something out, then you should. Finally, simplifying some radicals. I guess this isn't finally because there's one more thing to go as well. Simplifying the square root of a negative 160. Well, what goes into 160 would be 16 and 10. 16 is 4 and 4, and now we have a pair of 4s which get to leave as a 4. 10 is 2 and 5, which there's nothing else you can do. So we would leave this as 4 times the square root of 10, and then we need to have an I because it was the square root of a negative number. And if you want to write it this way, that would be fine as well. For the square root of 3/8, that's like the square root of 3 over the square root of 8. If you want to simplify the square root of 8 first, you could. Or you can just multiply both the numerator and denominator by the square root of 8. And now you have the square root of 24 over 8, because the square root of 8 times the square root of 8 is just 8. Factoring 24 is 3 times 4, or 3 times 8, and 8 is 4 times 2, and 4 is 2 and 2, so we have a pair of 2's which get to leave as a 2, and we have a 2 and a 3 left, which is 6, and now that is all over 8. And then the 2 and the 8 can simplify to the square root of 6 over 4. Finally, converting between forms, taking this and it is in root form, converting it to standard form, you just need to multiply it out. So x times x is x squared, x times a negative 2 is a negative 2x, 6 times x is 6x, and 6 times a negative 2 is a negative 12. And we still have all of that times 2. But we can simplify this first to get x squared plus 4x minus 12, and then multiplying by 2, it would become 2x squared plus 8x minus 24. Now then, if you wanted to take this and convert it to standard form, then you would start with this equation and convert it to standard form. The first thing you'd do is add 24 and get 2x squared plus 8x equals y plus 24. Then you would want to divide by 2 because you need to make the x term singular. And you would get x squared plus 4x equals y plus 24 over 2. Now is when you have to complete the square and take half of that number, which would be x plus 2 quantity squared. And because we're going to write this as a factor, then we have to add 4, which is 2 squared, and then we have to add 4 to this side to get y plus 24 over 2 plus 4. And we don't have to do anything with that as far as simplifying it, because now we have to get everything else to the other side and solve for y. So we're going to subtract 4 first. So then we'd have x plus 2 squared minus 4, y plus 24 divided by 2. Multiply this side by 2 and this side by 2 to get 2 times x plus 2 squared minus 8 and y plus 24. And finally subtract 24 to get 2x plus 2 squared minus 32 equals y. And that would be vertex form. Looking at another example, taking this and converting it to standard form. Remember, when you square this, you do not get x squared plus 16, because the squared doesn't get distributed like when you're multiplying. The squared means you have to write it twice and multiply it out. So you would get x squared plus 8x plus 16 minus 25 equals y. X times x is x squared. That's 4x, and 4x and 4x makes 8x. And 4 times 4 is 16. Combining, then you would get x squared plus 8x minus 9 equals y. And there we have standard form. Then if you're going to take that and turn it into root form, you would see, are there factors of a negative 9? That gets you a positive 8, and that would be a negative 1 and a positive 9. So then your factors would become x minus 1, x plus 9. And there you have root form. And this one, if we were going to take this and convert it to vertex form, first thing we would do is subtract 9. X squared plus 10x equals y minus 9. And then complete the square by taking half of 10, which is 5. 5 squared is 25 is what you have to add to both sides of the equation. And so you get y plus 16. And then getting y by itself by subtracting 16. And you'll have x plus 5 squared minus 16. And this then is vertex form. If we wanted to take that one and convert it to root form, what are the factors of 9 that add up to 10? That would be positive 1 and positive 9. So your equation would be y equals x plus 1 and x plus 9. And then there will be, like I said, a few questions from previous chapter. So we will see you tomorrow, and good luck with it.